to write that. We'll learn too. So an explicit formula is an equation, and I have quotes around that because you can't really call it an equation because that represents y equals mx plus b or ax squared plus bx plus c. But that really represents something that you should be connecting the points. And this is a sequence. Those points aren't connected. Remember, don't connect the dots when you're graphing. So it's an equation used to represent the nth term in the sequence. So the homework problems that you were asked to write a rule for the nth term. That rule is called an explicit formula. If there's an n in the equation that you're writing, that n represents the rule or the pattern for the nth term. So anything that has an n in it, any formula that has an n in it is called an explicit formula. So the n is there because you're taking a number, you're plugging it in to find a value in your sequence. So this little chart is organized for you to see like the type of sequence, the formula that goes with it, and then we'll try and like have an example next to it. So they kind of just look across and say, all right, it's arithmetic, so it needs to have this pattern, and therefore here's an example to follow that pattern. So when it's arithmetic, what does that mean if you have an arithmetic sequence? What are you doing to go from one number to the next, Isabella?
You multiply the same number.
Geometric. Yeah. There we go. So adding or subtracting the same number every single time. So I'm adding 2 every time. We're subtracting 5 every time to get from the first value to the next value, the second value to the third value. So arithmetic is a sequence that contains addition or subtraction to go from one number to the next. So there is a certain pattern that we can follow to try and come up with those equations. So 7 and 8. There's patterns that we can follow. Number 8 is considered an arithmetic sequence. So to try and write that pattern, it starts with a sub n because that's our sequence notation. Instead of f of x, it's a sub n to represent sequence. And then it says that's equal to a sub 1. What does that notation really represent? David?
Is that like the first number?
Yeah, that is the first number. So a sub 1 represents the first number, or we call that the first term in your sequence. That's what that represents. So we're going to use that first term in our equation to help us come up with this formula. N minus 1, that's your variable part. You can't do anything with this because you need to have a variable to have a formula or to have an equation, to have something to plug into. The D, the last thing, is called the common difference. That just means, what are you adding or subtracting with? What's the difference between the first and the second term? It has to be common because it has to be the same distance between 2 and 3, the same distance between 3 and 4. So you'll like this because it literally is plug in the numbers you know, simplify, and then you have an equation. There is no like trial and error once you know that it's an arithmetic sequence. So it has to be arithmetic in order to use this form. So the sequence we have here is 3, 5, 7. This really should have a dot, dot, dot accurate. It should continue. So to come up with the equation or the formula, we start with a sub n because it needs to be equal to something, and it can't be f of x, that represents a function. And then you start with a sub 1, which David said was the first term. So David, the first term in this one is 3. Then it says to add n minus 1 in parentheses, that quantity. We're not plugging in anything for n minus 1. What's the difference between the first term and the second term and the third term? What's the d value? So what are you doing to get from one number to the next? Aaron?
Adding 2.
Yeah. So the d is 2 because you're adding 2 to get from 3 to 5. You're adding 2 to get from 5 to 7. I'm going to put that in parentheses as well, just to show more time. Here.
You're subtracting, would the d be a negative?
Exactly, yes. If you're subtracting, d would be a negative. So we plug the numbers in. Now you just need to simplify to have a nice equation without parentheses. And in this case, simplify just means distribute the 2 through the parentheses that it's attached to, combine your like terms. So we have 3 plus 2n minus 2 our equation, combining like terms, we have 2n, the variable, place that in the front. 3 minus 2 makes a plus 1. So right here is our equation or formula for the sequence. So when you say it's arithmetic, now there's a way that we can write arithmetic instead of using like guess and check. And number 8, again up here, number 8, 4n plus 3 is an example of an arithmetic sequence. Any questions? So notice the 2, that difference is still in there. It's as a multiplication, 2 times the number. The n. All right, so 2 types of equations, which means there's 2 formulas. Each one gets its own formula. The second one is geometric, and going back to Isabella, geometric means? That's the one that's multiplying. So geometric is the one that we're multiplying to get from one term to the next. So you're multiplying by 3 every time. You're multiplying by 7 every time. You're multiplying by 1/2 every time. Its formula says, again, a sub n, sequence notation. Here's the a sub 1. That's still the first term. So anytime you see a sub 1, that represents the first term. R, in this case, is called the common ratio. A ratio can be written as a colon, it can be written as a fraction. And usually it's a fraction that you're multiplying by, or sometimes a whole number that you're multiplying by. So the value that you're multiplying by is the R, that's called the common ratio. Usually we'll put parentheses around that R guy to show multiplying instead of putting like a little multiplication symbol in there. Parentheses are usually what we use to separate them. So in this one we have 3, 6, 12, 24. So first thing, determine what are you multiplying by to go from one number to the next. Is that? 2. 2, yeah. So we're multiplying by 2. That means the R value is 2. So is it in this sequence? It says take a sub 1. So what's the first term?
3.
3. So we're going to take the first term. And then we're multiplying that with R. I'm going to put the R in parentheses just to kind of show the separation between the two. And Isa said you're multiplying by 2. And then that 2 gets n minus 1 as an exponent. So we have the first term, we have the ratio, which is what you're multiplying by to go from one number to the next, and then that R variable gets the n minus 1. Now, going back to chapter 7, we're going to bring chapter 7 back into the problems that we work with today, because we're going to be working with some exponents. Can you actually multiply those two together and make it 6 to the n minus 1? Is that,
No.
why not?
Whenever I did those like exponential problems, there was like a a, b, or b something, and I know you couldn't combine them because it had the exponent.
Yeah, good. So the one has the exponent, the other one doesn't. You can't combine them. Nice job, Isa. So you're not allowed to combine them. They're not like terms. An exponent and a non-exponential number don't get multiplied together. They have to have the same power. So the next 4 problems underneath, we're going to try and use these 2 formulas to see if we can now have like a method or a thought process to use to help us write some equations or formulas for arithmetic and geometric sequences. So the steps to writing the formula. 1, you have to decide if it's arithmetic or geometric. One or the other. You got to pick one. Because then, if it's arithmetic, we have a specific format to follow. If it's geometric, we'll use the other one. So looking at letter A, we have 5, 25, 125, 625. Caitlin, what do you think's going on with letter A? So if it's multiplying by 5, is it arithmetic or geometric? Geometric. So geometric, she said multiplying by 5, so that multiplying value is our R value. That's the common ratio to use from one value to the next. After you decide which sequence it is, then in the box, look at the little formula that you're using in the box. So Caitlin, what does that formula say we need to do?
Take the first term times 5.
So take the first term times 5, which is the R. What is the first term in this case? It's also 5. So the first term, here's a sub 1, is 5. You're multiplying that by the R, which is also 5, and then that's to the n minus 1 power. And that's it. So you can check to make sure it works by plugging a 1 in, or 2, or 3, or 4. If I plug it, let's say plug a 3 in here. So 3 minus 1 is 2. 5 squared is 25. times 5 gives me the third term of 125. So it does work. You can plug a number in to make sure that it works, to check to see that you're getting that value in your sequence. Any questions with A? So looking at number 2, we have 2, 5, 10, 17. What are we doing here? Seven.
Each time you're adding 2 more than you did the previous time.
Okay, so she said each time you're adding 2 more than the previous time. So this one we're adding 3 and then,
Adding 5.
so if I wanted to follow another one, then I would just add 9 and then 11 and then 13 and so on. Does that make it arithmetic?
No,
Why not, Sam?
because you have to add the same or subtract the same number every time.
Exactly, it has to be the same every single time. So this isn't arithmetic, and it's not geometric, so this is that case where it's neither. Now, when it's neither, you still have to come up with a formula. These are the ones that's the trial and error problems. They're a little trickier. So we need to look to see like what is going on, how do these numbers relate? Yes, we're adding 3, and then we're adding 5, and then we're adding 7. But these numbers are also really close to a special number. Sam?
Isn't like the exclamation point?
The factorial thing?
Yeah.
Not quite.
They're all 1 off of the square.
So Kate says they're all 1 off of a perfect square. So what do you mean by that, Kate?
It's gonna be n squared plus 1, right?
So she's saying it's going to be n squared plus 1. So just to kind of see like what Kate's talking about, if you have the number 5, Kate, number 5 is really 2 squared and then plus 1. 10, she said, is 1 number off from the perfect square. So 10 could be 3 squared plus 1. 17 could be 4 squared plus 1. So they're 1 number away from a perfect square. 2 is 1 squared plus 1. So that n squared plus 1 can be a formula that we use to find the next value. So I would take 5 squared plus 1, my next number would be 26. So when you say it's neither, you still have to try and come up with a pattern. Those are the ones that are a little trickier, because there's not a specific formula for you to use. Any questions on A or B? See if you can do C and D. So C is 150, 25, 12.5. D, we have 18, 12, 6, 0. Determine if it's arithmetic or geometric, and then use the formula if you say it's arithmetic or geometric that's provided in the box. If there's not one of those, then you have to trial and error your way through it. Try and write something down so that you can figure out what the pattern would be. So Sam, what do you think about letter C?
I said neither
Why?
because it's not like decreasing or increasing at the same rate, and you're not multiplying. Well, actually, hold on. What I got my correct equation here is an equals n minus half n.
Okay, so what are you multiplying by then?
0.5.
0.5, yeah. So this is geometric because you're multiplying by 0.5 or 1/2. You're dividing by 2. You're starting by 100. Divide by 2, you get 50. 50 divided by 2 is 25. 25 divided by 2 is 12.5.
Oh,
So if you're dividing by 2, the ratio is 1/2. That's really what you're multiplying by. So Sam, what's the first term?
n. Or 1, or even half.
No, what's the first term in the sequence?
100, sorry.
100. So the first term is 100, and then the r is 1/2, and that gets the exponent n minus 1 because that's the part that we're using then to get the third term, the fourth term, the fifth term, the sixth term. Questions with C? So letter D, we have 18, 12, 6, and 0. What's going on from 18 to 12, 12 to 6, 6 to 0? Isabella? Yeah, so if you're subtracting 6, the D is negative 6. That makes it arithmetic. So Isabella, that formula then says take
18 plus n minus 1 minus 2.
what's the D value? Yeah, -6. So the n minus 1 part, that's not changing. That's the variable part. It's not going to change. We plug in the first term. We plug in the D value. And now we need to simplify. So if we simplify this, we have 18, a minus 6n, and be careful here. -6 times -1 is a +6. So our equation should say -6n and then +24. Just be really careful with the negative signs. Two negatives combined to make a positive value. Any questions with writing a formula? So as long as it's arithmetic or geometric, now you have a pattern to use. You don't have to use like guess and check. There's no way to write them. Is it?
Are we gonna have to memorize these formulas?
Probably.
Oh.
It's 2.
Yeah, it's only 2.
Alright, so if you flip over to the next page, we're going to look at a couple of applications now. What else can we do with a sequence that's arithmetic or geometric besides just trying to write a formula for them? And the first one are 2 word problems that take you directly back to chapter 7 because chapter 7 was exponents. Exponents are geometric equations or geometric sequences. So the wording of this is almost identical to a problem that you would have seen in chapter 7. And there was a problem similar to this on that second semester cumulative review. Samara Reese invests $1,000 to open a savings account that earns 3% annual interest compounded monthly. Find the formula for the value of the account after n months. What does compounded monthly mean? Okay. Not raised to the 12th power, but something with 12. So compounded monthly with interest. David?
Do you divide by 12?
Right. We have to take our annual rate because that's what the rate is for the whole year, but we're earning interest every single month. So we have to take that rate and divide it by 12. So the first step would be to find the interest rate per month. If it said daily, then it would be per day. So David, if you take 0.03 and divide it by 12, do you happen to have a calculator? Yes, you do. So 0.025, that's sloppy. Put it underneath. So annual means that's what the rate is for the whole year, but because it's compounded monthly, every single month you're earning interest. So I need to find the percent that it would be, or the rate that it would be for each month. So now we have that rate. Now we need to come up with the formula. Does anybody remember how these start? So go back to chapter 7. What do you start with when you're writing a formula?
Like the initial amount.
Yeah, so you need to start with the initial amount. Well, we invested $100. So that's the initial amount. 1,000. I wrote 1,000. And then what do you have, Sarah?
Then like the rate.
And then we have the rate. That's called the rate of increase. What do you have to put with that rate of increase? Not 1 minus, 1 plus because it's increasing. So then you take 1 plus 0.0025 and then we'll raise that to the nth power because it says n months. A formula has to have a variable in it. So you take your initial amount, the rate of increase, it's increasing, so it's 1 plus. If it's decreasing, it would be 1 minus. And then it does need to be set to equal to something, so I'm just going to put a V for the value of the account. Remember, a sequence uses the n as a subscript, so V sub n. So if we just simplify this a little bit, we would have 1,000 And then 1 plus 0.0025 is just 1.0025 to the nth power. So this would be our formula to represent the value in the account. So I just use V for value because that's what it asked for. That is exactly the same thing we did back in chapter 7. So we took the rate, you divided it by the number of times it was compounded, and then we plugged it into the formula, or to write a formula. So if we want to find the value in the account after 1 year, we have $1,000 that we started with. Our rate of increase is 1.0025. What number are we plugging in for n?
12.
12. Yeah, there's 12 months in a year. So you plug in 12 in. So what is the value after 12 months? Sarah?
$1,030.42.
$1,030.32. So the initial amount, what you're increasing by, raised to the power of an n. This is actually a geometric sequence. So it has that same form. My first term times the ratio to the nth power. So it's an exponential equation, also a geometric sequence. The second one is very similar, except it deals with bacterial culture. Alejandro has a bacterial culture, because why wouldn't you be growing bacteria in your house? That increases by 10% each day. He estimates the current bacterial count to be 10,000. If you take AP Bio at some point here, you will make yogurt by growing bacteria. So yogurt, it has a lot of good bacteria in it, but you will do that at some point if you take AP Bio.
You eat it.
Yeah.
That's disgusting.
Yeah. So it says find the formula for the bacteria count after n days. I'm going to just use a B to represent bacteria. You can use any variable you want. Like I used a V because it said find the value. I'm using a B because it says find the bacteria count. So how do you start with your formula? What's the first number that goes in the formula? Sam?
10,000.
10,000, our initial amount. And then Sam in parentheses is
1.1.
1.1. Because it's 10%, which is 0.1, you're adding that to 1. If it was decreasing, if that was declining, we would subtract it from 1. And then n days gives us the n. So this is the rate of increase. Nice job, Sam. So then for part B, find the approximate bacteria count after 20 days. So take our formula. days, I guess technically we should have a little 20 here because it's the 20th term, 20th day. Sam, do you have a calculator out?
No, but
No, it's all right. This is going to help you.
Is it 67274.99949?
So we could probably say 67275 bacteria.
Oh, and also, can I use a
Yes, you may. So our bacteria count, this is only 20 days later. So it started with 10,000 and now it's 67,275. 10 days later. 20 days later.